Welcome to Lesson 1.4, Measure and Classify Angles. So the first thing that we need to do to measure and classify angles is to be able to define an angle. So our geometric definition of an angle, it is formed by the union of two rays. One ray is called the initial side. The other is called the terminal side. Then angles are measured by the amount of rotation from the initial side to the terminal side in degrees. And the way that we name angles is we can name them with a number, if there's a number given, with a single letter, the vertex. And we do that if that vertex is not shared with other angles, or the three letters with the vertex being in the middle. So if we look at the diagram here to the right, the vertex of the angle is where the two rays meet. It's that shared endpoint. So our shared endpoint in this case is A. So A is our vertex. Then ray AC and ray AB make up the two sides of our angle. So when we're naming an angle, we could name this angle CAB or BAC. That doesn't matter as long as the vertex is in the middle. The other way we could name this angle is simply angle A. And the angle symbol looks rather similar to the less than symbol right there. So example 1, I apologize, the diagram did not copy well. So example 1 says name 3 angles in the diagram. And I just left that reminder, the vertex is the point in the middle. So the vertex when we're naming has to be in the middle. So our diagram, I just finished drawing it here. We have point W, Y, and X all on our different rays, and they all share the endpoint of Z. So we have ray ZW, ray ZY, and ray ZX. So then, 3 angles in the diagram. One angle would be angle WZY. So from W to Z to Y, or that's the same as YZW. So that top angle here is YZW or WZY. Another angle is XZW, from X to Z to W, or WZ to X. So we can name it either way, it's the same angle. And then our final angle in the diagram would be angle YZX or XZY, as long as that vertex of Z is in the middle. So we have the 3 different angles. Then we're going to look at the first time we're using a postulate this year. And we'll get more into postulates, but postulates, what you want to think of, are basically rules of geometry, things that we accept as true and things that work every time in geometry. So postulate 3 of geometry is simply known as the protractor postulate. Now, this gets a bit confusing, but I tried to summarize it at the end. So what it says is consider OB and a point A on one side of OB. The rays that form OA can be matched to one of the real numbers of 0 to 180. The measure of angle AOB is equal to the absolute value of the difference between the real number for OA and OB. I don't care if you know anything about that postulate other than the protractor postulate is the postulate that allows us to measure angles with a protractor, meaning it allows us to measure them from 0 to 180 degrees. So the protractor postulate is explaining how a protractor works, really. We look at our initial ray, which is going to be lined up with 0, and then our other ray, and we measure that difference to get the degrees. So protractor postulate, just know it allows us to measure angles with a protractor. Classifying angles. So there's a few different types of classifications of angles, common types in this case. Acute angles are any angles where the measure is less than 90 degrees. A right angle is exactly 90 degrees. An obtuse angle is any angle more than 90 degrees. And a straight angle is 180 degrees, or think of it like a flat line, or a pair of opposite rays. So those 4 terms are 4 classifications of angles. So if you're ever asked to classify an angle, it means classify it as acute, right, obtuse, or straight. Example 2 says, use the diagram to find the measure of the indicated angle, then classify the angle. So we're looking at our diagram here with the protractor and the different rays. Remember, when you're measuring an angle using a protractor, you always want to line up that little dot or opening, the bottom of your protractor, with the vertex, and then make sure that the 0 is lined up with one of the sides. So the first one they ask us to measure is angle KHJ. So from K to H to J. KHJ. So KHJ, measuring here, we know it's less than 90 degrees. So I'm going to use the bottom measurements. And it is midway between 50 and 60. So we are going to say KHJ is approximately 55 degrees. So 55 degrees, to classify that, less than 90. So that would classify as an acute angle. For GHK, from G to H to K. So that one is more than 90 degrees. So as we go from G all the way over here to where K intersects, I'm going to use the upper numbers, midway between 120 and 130. 125, so 125 degrees, which is an obtuse angle. Then GHJ, G to H to J. So the vertex is H. It makes a flat line. So flat lines measure 180 degrees, and they're classified as a straight angle. And then GHL, from G to H to L, makes a perfect 90-degree angle. So that would be a right angle. So you can write in the words acute, obtuse, straight, and right. For 3, name all the angles in the diagram, and then which angle is a right angle. So my different angles, I could have angle P to Q to S. I could have angle P to Q to R, and I could have RQS. And then our angle that is a right angle, the way I know that is this little lightly drawn square. That's the symbol for a right angle. So PQ QS is our right angle. Now, example 4 asks us to draw a pair of opposite rays. What type of angle do the rays form? So, opposite rays always, in this case, always, because we're dealing with Euclidean geometry, will create a 180-degree or straight angle. So they create a 180-degree straight angle. Doesn't matter if we draw them vertical, horizontal, or oblique with a slope. Our opposite rays, so BA and BC, will form a 180-degree angle. So a straight angle. Another postulate is the angle addition postulate. So the angle addition postulate reads, if P is in the interior of the angle RST, then the measure of angle RST is equal to the sum of the measures of angles RSP and PST. So if we look at this diagram over here on the right, angle RST is the big angle, P is in between R to T, so it's in the middle or interior of that angle. Then what that theorem says, or that postulate says, is angle RST, the big angle, is equal to the sum of RSP and PST. So simply put, the two parts, this angle and this angle, added together give us our total angle. So if we add these two interior angles, the sum of that will equal the measure of the big angle. That's the angle addition postulate. So in example 5, it asks us to find the indicated angle measure. So they gave us some information. Given the measure of angle LKN is 145 degrees, find the measure of angle LKM and the measure of angle MKN. So I'm looking at my diagram right here, and what they told me was LKN, so this big whole angle, is 145 degrees. So I can also know from the angle addition postulate that angle LKM, so this one right here, and angle MKN, this one right here, together equals LKN, my bigger angle. So I can take that idea and use the information they gave me to set up an equation. Angle LKM was 2x plus 10. Angle MKN was 4x minus 3. Those two angles added together equal 145 degrees. So 2x plus 10 plus the 4x minus 3 equals 145 degrees. Then we are going to solve for x. So we'll simplify on the left. 2x plus 4x is 6x. 10 minus 3 is a positive 7. So 6x plus 7 equals 145. Subtract 7 from both sides. 6x equals 138. And divide by 6, so we know x is 23. But the answer to our problem is not what is the measure of x. The question was, find the measure of angle LKM and the measure of angle MKN. So let's start with MKN. MKN is going to be 4x minus 3. I got that info from right here. So then when I plug in, x is 23. So 4 times 23 minus 3. 4 times 23 is 92. Minus 3 gives me 89 degrees. So then, if I need to find the measure of LKM, in order to find LKM, what I would do is I would take my 145-degree total and subtract the 89 degrees for MKN, and that will give me the answer for LKM. So in that case, it would be 145 minus 89, which, if I'm not mistaken, mental math would be 56 degrees. So LKM is 56 degrees. And we can double check that. If we wanted, we could plug 23 into 2x plus 10. 2 times 23 is 46, plus 10, 56. In part B, given that angle KLM, so now we're looking at this diagram down here, KLM is a straight angle. Find the measure of angle KLN and the measure of angle NLM. So in this case, we need to start with figuring out the value of x. And how we do that is the angle addition postulate. We can take the 10x minus 5 from KLN and the 4x plus 3 from NLM and set that equal to the total of 180 for KLM. So then 10x minus 5 plus the 4x plus 3 equals 180. Solve for x, so we simplify on the left. 14x minus 2 equals 180. Add the 2 to each side, divide by 14, and x equals 3, or 13, sorry. X equals 13, I can read. Then we move on to answering the measure of our angles. So we're going to take this value of x being 13 and plug it into both of these expressions. So for KLN, 10 times 13 minus 5. 10 times 13 is 130, minus 5 is 125 degrees. Then for NLM, I could do 180 minus 125 and get 55, or I could plug it in. 4 times 13 plus 3. 52 plus 3 is 55 degrees. And then our last one of these types is C. So we know angle EFG is a right angle. EFG is a right angle, that box symbol. Find the measure of angle EFH and of angle HFG. So again, we're going to set it up. The two parts equal the total. So 2x plus 2 plus x plus 1 equals 90. 2x plus 2 plus x plus 1 equals 90. Solve for x. So 3x plus 3 when we simplify equals 90. Subtract 3 from each side. 3x equals 87. Divide by 3. And x equals 29. Now we're going to take that 29 for x and plug it into each expression here to find each angle. So angle EFH was 2x plus 2. Plugging in the 29, 2 times 29 plus 2 gives us 60 degrees. Then for HFG, x plus 1, 29 plus 1 is 30 degrees. 30 plus 60 equals 90, which was EFG, so we are correct. And then the final concept that we're going to explore in this lesson is the idea of congruent angles. So congruent segments meant two segments that have the same length. Congruent angles are two angles that have the same measure. So 55 degrees or 36.2 degrees. So angle measures are equal is represented by this. A lowercase m next to the angle symbol means measure of angle. So that would be the measure of angle A is equal to the measure of angle B. Angles are congruent. We have that congruent symbol, the equal sign with the little squiggly above it. So this would just read simply, angle A is congruent to angle B. So if the measures are equal, the angles are congruent. Example 6, I'm not worried about. It's in the book if you want to look at it, but that diagram was too hard to copy over to make it visible, so we're going to skip that one. And we are going to look at example 7 and the idea of congruent angles and how we know that based on symbols. So in A and B, we're going to use this shape over here. 1, 2, 3, 4, 5 sides. It's a pentagon. So looking at the pentagon over here, they want us to identify congruent angles. Now ignore the numbers because those came in part B, but just the symbols on the arcs. The double arc here on P and the double arc here on R mean R and P are congruent. The single arc on T and the single arc on S mean T and S are congruent. If Q would have a single arc as well, then Q, T, and S would all be congruent. So double arc and double arc match up. So P and R, angle P is congruent to angle R. T and S, angle T is congruent to angle S. In part B, it says, in the diagram, the measure of angle PQR is 130 degrees. So I just labeled up here, PQR, this top angle, 130 degrees. Then the measure of angle QRS is 84. QRS is this angle here of R. So if that's 84, I know over here is also 84. And the measure of TSR, so T to S to R, meaning angle S down here, is 121. So also down here is 121. So find the measure of the other angles in the diagram. Angle QPT, QPT, so this angle here is 84. And then STP, STP, giving us angle T down here is 121. And then lastly, we already explored what a segment bisector was. Now we have an angle bisector. An angle bisector is simply the ray that divides an angle into two angles that are congruent. So in example 8, we'll look at an example and an image of that. In the diagram at the right, ray YW bisects angle XYZ. So angle XYZ, this bigger one, is being bisected by YW, meaning angle XYW and ZYW are congruent. The measure of angle XYW was 18 degrees. Find the measure of the larger angle XYZ. So I know if XYW is 18, that also tells me ZYW is 18. So XYZ is 18 plus 18, or 36 degrees. And then our last example, example 9, is asking us to do a drawing. It says angle MNP is a straight angle, and ray NQ bisects angle MNP. Draw angle MNP and ray NQ. Use arcs to mark the congruent angles in your diagram and give the angle measures of these congruent angles. So in this case, I knew that we had MNP and we drew that as a straight angle. So that's just MNP is a straight line. Then NQ is bisecting that into two equal parts. Well, 180 divided by 2 is 90 degrees. So I know that it needs to make two 90-degree angles. So when I drew ray NQ, I drew that straight up. So then I knew angle MNQ and PNQ are both 90 degrees, represented with that little purple square instead of an arc. And those two purple squares mean each angle is 90 degrees and they are congruent.